Well, good morning, good afternoon, good evening, everybody. Welcome to another installment of a beautiful podcast on this little YouTube channel. And I'm joined today by my friend and legendary contributor to Neo4J, Jennifer. And how do you pronounce your last name, by the way?
Reif.
Reif? Okay. I
hmm
never know.
It's
You know,
it's German based.
it's a nice name, but I just don't know how to pronounce it.
Yep.
I am not very smart. And so that's
We know
makes life
that's
hard.
not true, Josh.
No, it makes it more complicated. Life has never been very good with like if it if it was easy, nobody could do it, and it would be easier still if I wasn't so deficient. So okay, so the name aside, I cannot we caught up at J Focus in Stockholm
Yes. Yeah.
where you were doing one of your amazing talks, and we had I haven't caught up with you in a minute, and you said how many years you've been at Neo4J now?
8.
No.
Yep. I just hit 8 last Friday, which is crazy
Correct.
to me.
That's going by too quickly. And
Yeah.
so, I mean, Neo4J is, this incredible organization. And I thought about like, okay, we haven't talked in a minute, and then I realized, wait, I haven't even done any Neo4J content in a hot minute either. And between the superstar that you are and the amazing technology that Neo4J represents, I cannot tell you how much we needed you on the show today. So thank you for being here. Um,
Happy to be here.
what do you do? I mean, can you describe for the audience your role at this juncture in life?
Sure. Yeah. So I've been for the last 8 years now a developer advocate at Neo4j. Before that, I was just a regular programmer. Um,
A
and
muggle.
Right, exactly. Before I catapulted into this interesting and unusual role. But I love advocacy and I'm still loving it 8 years in. It is never dull. There's always something new to learn, something new to explore, something variety of different ways you can share that.
Yeah.
That's one of the favorite things about this job is just the variety of different ways that you can communicate with Java developers in my case, and share what you've learned along that journey. So learning plus being able to share that with other people is the best part of this.
And it's a skill too, isn't it? I mean, it's not. I mean, I know this is going to sound really cliche, but if you're an engineer or if you're in a life sciences profession of some sort, something in that learning is not just a fun thing to do; it's a requirement,
Yeah.
And so, and I think especially if you're doing engineering where it's like research and development, I think learning how to learn, knowing how to learn, how to sit down and look at a thing you don't know and then know, is very important. But because it's constantly changing, the
Yeah.
nature of what you're doing is constantly changing. And then similarly, I think for advocacy, because by our very nature, we are hopefully on the zeitgeist of, you know, whatever it is we're all doing. Hey, there, wait, is that word pronounced in the same way as your last name? Wait, say your last name again.
Which one? Rife.
Zeitgeist, Reif, Zeit.
Yeah. Very
I could have
similar.
just
Yep.
followed from that.
Yep.
That's awful.
Yeah, I had
Darn.
when I first joined Neo4j, actually, I had like a whole slide
Yeah.
of things that are pronounced the same way, that are spelled the same way
No.
to try to help people, like just for fun. It wasn't anything like needling or mean, but just kind of for fun because it does always get pronounced incorrectly. And so I had like, Heineken and all sorts of things. It's all EI. And yeah, it's the German based, which means the second vowel gets the sound. So yeah, it's funny and it's entertaining. But yes, poltergeist, same deal.
Oh, so but did you have Zeitgeist?
No, I did not have that. I
Oh,
should.
no, because no, but that would be worse. Like I saw, what was that? Uh, like somebody there was a meme like years ago when people were talking about how terrible La Croix, the lightly flavored water beverages, and
Yeah.
one of my favorite comments on Reddit was, how do you even pronounce it? Is it like La Croix or whatever? And then somebody said, no, it's very simple. It's just pronounced exactly like Charlevoix, And of course, how do you pronounce that, right? If you see it written out, like what does that mean? So if
Right.
you had Zeitgeist, people are like, well, okay, great, but how do I pronounce Zeitgeist now?
Right.
Um,
Exactly. I have to pick things that are mainstream enough.
yeah. Okay, so that's great. You had a slide. I don't feel so stupid then. Apparently, I'm not the first one to trip over this.
No, it was funny actually. So on my way to JFocus, I
Yeah,
landed in Munich, and one of the gate agents had me come up because I guess I got put in an exit row or something like that. And so
yeah.
they pronounced my name. I'm like, oh my gosh, it's the first time ever that somebody who has never met me before pronounced my name correctly. But of
Oh, you're
course,
in
it's
Germany,
Germany, right?
the
So
fatherland.
yeah,
Yeah,
so yeah, it was so funny.
that's awesome. That's awesome. Yeah, and Germany is very frustrating for me as an American English speaker because I'm really sick of people knowing more English than I do when it's their second language. Very problematic for me. I can't tell you how much that bothers me. Like, I've had people correct my grammar, in Germany, and they're right too. So it's even
Yes.
more like
Language is tricky.
just really, come on, let me have a like. Oh, it's so good. Anyway, so you're an advocate at Neo4J,
Yeah.
and you spend time apart from teaching the simpletons like myself how to pronounce names. You spend time in graph databases. Which can you
Yeah.
explain what that is? Like, what is Neo4j, and why would I use it instead of say, uh, a pencil and paper or a SQL database or something? I thought I already had a
Right.
relational database. What does this do?
Right. Yeah. So where something like a relational database will store things in rows and columns, you're relatively, I guess, for lack of a better term, it's kind of these data is organized in these neat little bundles. Um, But when you want to try to connect those, you do that all at query time, right? You construct your SQL query so that it does those joins and connects across tables using foreign keys and so on. To avoid some of that hassle, because as your data set grows and gets more complicated and you have a lot of relationships and a lot of basically hops between tables,
Right.
to kind of combat some of the problems that you run into when you're dealing with multi relationship data sets inside a relational database, you can instead go with something like a graph database, which is designed to take those nice neat little bundles and actually store the relationships on disk.
Yeah.
And then when you query, you're just following the relationships that are stored there in the database. So it's an entirely different data store format. You're taking those entities and then you're connecting those entities, or what we call nodes, connecting those with relationships. So it becomes this very, very readable network, basically,
Yeah.
of data. And it is still a database. People often ask, well, is it like a visualization layer, or is it a graph layer in memory type of thing? And no, it's actually a database. It's being stored to disk. And it's really just chasing these memory pointers around, following the node relationship patterns all across the data store.
And I think that uh, SQL. I think uh, it's sequential disk-based access, right? It's
Correct.
foreign keys are an optimization to allow people to jump to the right place in a table, in a
Yeah.
scan, in a seek. But nowadays, we have SSDs. We have so as a result, whenever I've used Neo4j, it's not just it doesn't just more naturally map to my mental model of the data. It is also blazing fast. You
Yeah.
know,
Yeah. It
millions and
continues to
millions of
improve.
traversals per second.
Yeah. Yeah, and that's one of the powerful things actually about thinking of data in a graph, because human minds automatically will sit down and draw a graph. When you're
Yeah,
looking at, any type of data model or a process or I don't know, a social example, you will automatically sit down and draw circles and lines to say these are how things are connected. Here's where the data is being moved, or here's how this process is working. You draw boxes and arrows, or circles and arrows, or whatever it is. That is a graph. And so to be able to actually store the data as you
yeah.
would model it in the real world is extremely powerful.
You don't have the object impedance mismatch either because
Correct.
they're objects,
Yes.
right? Like you describe them in your mind as objects, you relate to them as other objects, and they have relationships, and you write that to the database exactly as that, and then you query it exactly as that. There's no dissonance. There's no cognitive hurdles to get across. So you actually you advance your. I find that when I'm writing that kind of code, I tend to move more quickly because I'm not. The only time where you have to challenge or adapt or in any way transform that relationship is when you're trying to represent it over the wire. So I send, JSON or something like that.
Sure.
But at that point, the hard part is done, right? I've already figured out the storage model, the query model, and the business logic in terms of the same common domain model.
Right. And that's one of the things actually that is super powerful about graph databases with Java, or I would imagine this same way for any object-oriented programming language, is that mismatch is very, very minimal. I mean, sure, you probably have some use cases where there's slight translation differences, but relatively low. So when you're creating your applications and you're building your, Java apps, the alignment between your application data model and your actual database model is very, very similar. That's one of the things I have found so cool. A lot of times when I would build applications working with relational databases, you would have some sort of translation step. Well, okay, here's how I need to basically retrofit the database model as an application model to make it work within my Java app or whatever it is. Yeah. And same thing goes back and forth, right? From your Java app going down to the database, you have to make some translations there. But with something like a graph database and your Java application, there is very little translation that needs to occur there. So the application model pretty much mirrors your database model, at least in my experience.
Yeah.
So the idea of like the physical model, the conceptual model, the logical model, whatever it is, they're pretty much the same when you're dealing with graphs.
And so when you talk about that model, I mean, you mentioned you invoked the idea of somebody drawing a graph on a piece of paper. You're not talking about a bar chart graph. You're talking about a mind map kind of graph, like you've got a hub and you've got other nodes adjacent to that hub, and you've got lines.
It's more like how you would draw like a data flow or a process flow,
right? Okay.
At that point, so yeah, it's a little funny because we often tease within Neo4j, you have bar charts and histograms and pie charts and things like that. It's like, okay, those are charts. Those aren't graphs. There's a difference. A chart is a visualization representation, where the graphs, the way that we think of them, is connected data.
Right. So this is a data model that prioritizes relationships, unlike SQL databases where relationships are just an optimization for disk access.
Right.
And in a graph database, the relationships themselves have semantics, right?
Yes.
Can you give an example of that? Or don't mean to put you on the spot, but
no, that's okay. So just taking a very simple example of, Jennifer Reif works for Neo4j. That works for is that relationship. It's defining how the Jennifer Reif entity, the person, the node, however you want to term it, is connected to the Neo4j company entity. And that relationship could be a variety of different things. It could be I contract. It could be I like their page on whatever social channel. It could be I happen to live in the headquarters city or whatever it is. But no, I'm actually defining this relationship as no, Jennifer works for Neo4j. This is the type of relationship this person has to the company. And then I could also add additional metadata to that. For instance, I might have a start date. Or what type of job role or position I might have worked in. That all gets added to the relationship, because if for some reason I no longer work for Neo4j, then those properties, those details about that relationship also disappear with the relationship.
Wow. And can you have multiple relationships? Because you mentioned you could have liked them on social media and you work for them. That's two different relationships, but they both point to you and to Neo4j.
Right. And it totally changes the dynamic of that, right? Because not only do I work for them, but I also like their technology and I follow their social platforms, and I might also be a guest on their YouTube channel, or I mean, all sorts of different types of relationships. And it really just depends on what type of use case you're looking to create here.
And this is a bidirectional link, isn't it? So from the perspective of Neo4j, they could say they employ you, maybe, or it's a different relationship, but they have a view of it as well.
Right. And there are certain cases when you want to create a separate relationship. For instance, I think always the example was like on Twitter or X, where you can follow somebody, but they might not necessarily follow you back. So you can create a relationship. Jennifer follows Neo4j, But if they don't have the reciprocal relationship, then that's not a full circle there. That's totally different.
Oh,
However,
right. That's a good point.
something like, a person is married to another person, the reverse is automatically true.
Right.
Or same thing like for Facebook. If, I friend the Neo4J page, then
Right.
guess what? They're automatically connected back to me because that
Right.
relationship is automatically bidirectional by default. So it
That's
really
a
just depends on your data model there.
that's a really great example. The Twitter one. How would you model that in a SQL database? It would be fun, but not useful, right? It would be
Right.
painful.
And very, very tricky when you're trying to find, what other pages I might have liked, that
Right.
Neo4j
Oh.
could possibly follow and all sorts of interesting things.
And you'd have I don't know. I feel like you'd end up having a lot of extra tables to describe what are simple things in Neo4j, just relationships, you know.
Yeah, and
Um.
these are the things that as prior to my Neo4j experience, I just never even thought about. This was just the way you model data. But when I got introduced to Neo4j, it's like, oh, I never thought that you could do something like this. And it's not a silver bullet. I mean, it doesn't attach to every use case. But on the other hand, for those use cases that are just really complicated in other data stores, Neo4j is an excellent option to add to the tool belt.
Right. And it so now when it comes to query time, I'm not writing SQL, am I? I'm using a different language invented
Correct.
by our friend Michael Hunger and the team.
Yeah. So
Cipher.
yeah, Neo4j created Cypher years and years ago. That has now since morphed. There are other query languages
Really?
out there for graph databases. Yeah, there's Sparkle and Gremlin. Gremlin's
Oh,
probably
right.
one of the other major ones, but you have a few others out there too. And now, of course, I think it was back in, was it 2024 or 25? Now I have to scratch my brain. That the graph database vendors came out with a graph query language standard, ISO standard. So it's the
Oh,
first ISO query language standard since SQL came to be years and years and years ago. So there is now a ISO standard for graph query language, and it's called GQL or GQL. And Cypher and several other languages and database vendors all came together to help kind of solidify this standard across the entire tech industry.
that is cool. It does it. What does it look like? Is it kind of like Cipher or?
It's very similar to Cypher, but it has actually pulled in some things from SQL, from other graph database query languages, and all sorts of things. So it's a conglomeration of a little bit of everything. But of course, Cypher, being one of the first out there, was heavily a heavy
Influential?
influencer of GQL.
This is okay. I'm hoping I can persuade you to stick around after the podcast and we can do a little live stream demo. Maybe you could
Yeah.
show us some of that if it's convenient.
Yeah.
Wow, that's interesting. I didn't know about that. So this new language, because so for people listening to the podcast, Cipher is really neat because you write ASCII art. You just
Yeah.
do a little, you draw, you literally just if you were to open up Notepad or Vim or whatever and wanted to describe a relationship, you'd probably draw an arrow sign pointing to something else, and then another arrow sign pointing to that thing or pointing away from that thing, or both. Um,
Exactly.
and believe it or not, you've just expressed a graph in GraphQL in Cipher. So not
Yep.
GraphQL, Cipher. And so that query language really easy to like get into,
Yeah.
because it's just naturally you might accidentally recreate it. People,
Yeah.
if people didn't know anything about Neo4j but wanted to talk about graphs, they might accidentally recreate Cipher.
Yeah.
And how does that work?
Yeah. It's one of the things that I have found most, I guess, easy to go from other things into Cypher. The
Yeah,
thing that catches you off guard is, of course, other query languages are not so easy to comprehend just by looking at them.
right.
So you're like, wait, is it actually this simple? Yes, yes, it really is. Now, there are some really complex things. We can do some very complex graph pattern filterings and traversals and things like that, of which I am still learning a lot of the ins and outs.
Yeah.
My Cypher knowledge, I would say, is maybe intermediate. I'm not anywhere near in-depth advanced yet. I'm still progressing and working on that. And the thing is that Cypher has changed a lot, and GQL is continuing to influence a lot of those changes as well. So the language adapts over time. But looking at it, you can very easily see, person works for company,
Yeah.
company has social page, social page mentions event, event located in city. I mean, all of these things are very easily expressed in Cipher and
Yeah.
very easy to retrieve those patterns from a graph database.
The interesting thing there is because you've got this concept of nodes, and those nodes have relationships. So the nodes are the actual objects,
Right.
and the relationships are maybe ad, adjectives. I don't know, whatever. They describe the nature of the relationship. But the
Verbs.
nodes themselves, it's very easy in Cipher to say, I want to find a thing that has another thing in common with another thing. It doesn't matter how many hops there are in between the first thing and the last thing.
Right.
You're not just querying table A and table B. You can say, find me anything that allows me to make this link from here all the way to the other side of the graph. It
Right.
might be a thousand hops away, but the graphical language makes it trivial to express that, which I think is super, super interesting.
Yeah, and that's basically a pattern depth or however many
Yeah.
hops, traversal depth. And it's I could look at, okay, what are the connections between Jennifer and a particular event, and it might hop through, the Neo4J pattern that I just described a second ago. Through, I follow their or I work for the company. They have a social page, they have an event that's on a location,
Right.
etc. Or it could hop through and actually find, oh wait, Jennifer is actually a speaker for this event, and it
Right.
can find that pattern as well, and it's a much shorter pattern. So no matter what the pattern is or how long that pattern is, you can specify, hey, I just want to find the connections between Jennifer and this event, and it'll find all patterns that match that up to whatever depth you might specify.
Right. And this is why I think a lot of people uh, Neo4j lends itself to really large data sets, and the one that I think might be illustrative, that was really illustrative for me, um, was the Panama Papers some years ago. The researchers had this huge trove of documents. For people who don't know, there's this thing that went wide open, and it blew wide open the sort of murky sort of goings ons in I guess there was a company I guess it must have been Panama, right? And they had helped people avoid tax around the planet, and
Yeah.
so there's these troves, thousands or millions or whatever of documents. I
Yep.
don't know the number offhand. It's been many years now, but there's this huge trove of documents, and so it's very hard to make head nor tail of all of this of any piece of data in isolation. But if you throw it into a graph and you just say, hey, there's this person, that person, this person knew this other person, but there's no link directly to the other one over here yet. But as you start to throw in more and more things, the connections start to become clear, and it's very,
Yep.
you know, the connections become clear after the data is in there, versus with a SQL database where you have to make the connections first,
Right.
right? And
Yep.
then you're unable to make more new connections if you discover them.
Right. And you have to be looking for somewhat of a specific pattern in a
Yeah,
SQL database. So you have to
yeah,
kind of know what you're looking for. Not
right.
necessarily exactly, but I mean, just at least generally, like, hey, I need to hop through these tables. And I think there might be a connection between these two tables somehow through this particular pattern
Well, there,
specification,
right,
and do that. Where in Neo4j, one of the things that it does really well is a use case like fraud detection,
right,
where you might have people who are money laundering or passing sensitive data or whatever it is, identity theft. And you can find, oh, this person is living at the same address with this other person, and they're sharing a personal identifying information, or they're passing like small transactions to this small circle of friends. That's
right,
really easy to see in a graph and much harder to find in a relational database. Not that it can't
right.
be done, but it's just less.
You have to know what
um,
you're looking for in the first place, which is not
exactly.
always, what's the point?
Yeah.
Yeah, with a SQL database, you're asking it to give you data that you expect to be there. With
Right.
a graph database, you're asking it to tell you what data is there given a pattern,
Right.
and it might be surprising, which is really cool.
Yeah.
It unearths new relationships. So this all sounds magical, but one of the things, well, I mean, it does, right? It is, the result is magical, but um, it's not it's not it's very accessible. It is.
Yeah.
I think people could. What's the easiest way to get started with a database proper? And how do you? Is it can you just still run the Docker image and go to that console and
You can
start?
absolutely do that.
Yeah.
Yeah, if you're already familiar with Docker, I like to. That was one of the first things I actually did when I started learning. Is I was familiar with Docker already. I was like, oh, Neo4j has a Docker installation. I'll use that. I'll spin that up. And so I highly recommend whatever medium, platform, database technology you're used to working with, see if there's an avenue for you to do that similarly with Neo4j. So we have a Docker installation. We can spin up cloud databases. You can use your cloud vendor of choice, and you can spin up a community or an enterprise edition on one of those platforms. We also have a cloud database as a service. It's called
Nice.
Neo4j Aura. We also have free tiers of that. So if you don't want to spend any money at all, there's no credit card required. You can just spin up a free instance, and there's a few preloaded data sets you can dump in, or you can load your own. There's several examples also out there on community channels and GitHub projects that you can just kind of copy paste, load scripts and things in, and dump some data in there and just start exploring.
So the Aura thing, is that neo4j.com, or where do you go for that?
Yeah, it would be, let's see if it's, is it aura.neo4j.com? Let me check. Nope. neo4j.com/auradb or Aura.
AURADB.
Yes.
Okay, I'm going there right after the show. That's I have so I've been meaning to get an account, and I've just been lazy, and frankly I think this year I need to play with it more, and the reason is because first of all, it's always been really easy to use Neo4j with Spring. Fun fact for people in the audience who don't know, the very first Spring Data module ever written was Neo4j, right?
Yep.
Emil, how's Emil, by the way? I haven't talked to him in many a moon.
As far as I know, good. We haven't actually connected the dots in a long while either, but
Emil Ephraim, founder of Neo4j, he and Rod sat down. Rod Johnson, the creator of Spring, sat down and worked on this. Legend goes in 2010, and we announced it. The first Spring Data module was a collaboration from those two amazing people. So,
yep.
Obviously there were many other modules that would follow, but the very first one, right, was there. So it's really easy to use from Spring, and maybe
Yes.
you can, if I can persuade you to stick around, maybe a little bit later, we can do a different stream and we can talk about that. Because there's a really nice Spring Data integration.
Yes.
But and that's always been true. That's been since 2010 at least. But the world's changed. Data is different. It's useful in it's not just analytics and querying now. There's this new AI thing, right? And we have there's an actual story here for a vector store use case in Neo4j and Spring AI as well. What is the knowledge graph? How does the graph serve those who are working in the world of AI? Can we talk about that?
Yeah, absolutely. So as with most things, with AI, it's still continuously evolving, and there's new and greater things coming all the time. But one of the biggest opportunities that Neo4j had when AI started, everybody was reaching for a vector store, and vector stores are great for things like naive RAG or easy RAG, which is where you're just doing a similarity search or semantic search, if you will.
Right.
And that works really well in most types of databases because you're looking for a numeric calculation against a similarity algorithm. In most cases, cosine similarity or Euclidean distance, whatever it is. And that's retrieving the semantically similar chunks, if you will, whatever, if that's text or images or whatever it happens to be. The thing that is really powerful about graph is the idea of those relationships. So now not only do you have the chunks that you've created embeddings for, and you can do RAG with those to pull semantic similarity, but you can also tack onto that by pulling the related entities to those similar chunks. So now you have the connected context basically of whatever you're pulling for RAG. So something like the example I've been using a lot lately is book descriptions or book reviews. So you create an embedding for the book description or book review, and now you want to find books with a particular topic or theme. Most of the time right now, you walk into a library and it's very, I don't know, I guess hierarchical in the way it organizes books. And to find
Right.
something, for instance, in science fiction that I might like, it's a very ad hoc type of pull things off shelf, see if it looks interesting, read the description, see if it fits like the things that I like, right?
Right.
But RAG, let's just stick with traditional vector RAG. Now I can say, hey, I like this particular trope, or I like this particular character dynamic, or I like this particular story arc, or whatever it is. And now semantic similarity can pull those very specific criteria because it can now compare the numeric representations of that to numeric representations of the book descriptions or whatever it is and retrieve the most semantically similar. But now, let's say that's just book descriptions. Maybe I want to find books that are published by a particular publishing house within the last 10 years, or I want to retrieve like what are the ratings on Goodreads for my friends
Right.
on the Goodreads platform, whatever it is. That's all relationship hops, and that's stuff that is very relevant, but you wouldn't get from just a traditional semantic search.
Right. Oh, and not to mention you can say, okay, I want to find books with this trope or whatever, and that gets you part of it. But then I find out I discover I like this new category. What are the other books of that category? That science fiction or whatever. That's cool.
Yeah. Yeah.
Wow. Yeah. Okay. So I haven't. I'm being 100% honest here. I haven't used the Spring AI Neo4J vector store yet, but now I'm kind of keen on trying it out. It's already there. You can go to, for people who don't know, start.spring.io, and
Yep. And if you're looking for examples, my GitHub has several because that's what I've been working on the last couple of years with AI. Again, Spring
oh
is a great place to get started. It's something I was already familiar with, so it's like great.
yeah.
Let's tack on the AI capabilities now with the stack that I'm already familiar with.
Oh, okay. Now I know I'm going to ask you about later. I'm very excited. That's so cool. You can help shortcut my haircut my exploration to the unknown and make it known.
There you
Um,
go.
that's super good. You hear about the knowledge graph, you hear about people using this in AI, and you're right. The limitations of RAG for complex data sets become quickly very obvious and apparent.
Yeah.
And I hear people talking about how they're using knowledge graphs to, what is it called? Graph RAG is the
Yep.
other term I've heard, right?
Yep.
And I guess that's what you just described.
Yep. And then even just going one step further, so now I almost feel like the last probably year or so, uh, people have moved beyond RAG, and now we're talking about things like agentic and MCP and
Yeah.
memory and all this sorts of stuff. Also, ironically, have great overlap with the graph story, right? All these
Right.
connections. It's context. It's all context. And so being able to, we kind of have been using this term context graph. And really, that's just documenting business decisions or the why of how things got to where they are, why certain decisions were made, why a certain processes might have kicked off, and what were the results from that. Or looking at things like chat memory for, okay, here's all the previous context. How can we utilize this to make either the continuing conversation or future processes and business reports or whatever it is better optimized in the future based on everything that we've learned from the past? It's documenting all of that in a graph.
Wow.
And agents need that shared context. They need to be able to talk to one another, and graphs are another good way to document and really not visualize necessarily, but store all of this information to then surface when it's needed.
Yeah, and it's a. I mean, is it hard to encode it in the way that the model can consume it, or how does that work? Do you just, I guess you
So
just stream it
that takes
and
some
write it out,
optimization for sure.
right?
Yeah, I think it's really the experience that I've had at least is trying to define sets of tools that can recall very specific things, right? So we went from being one agent who will do tons of different things, and now we're looking at a bunch of different agents that do very specific, limited things. So you have a tool that will do a RAG call. You'll have a tool that does a API call. You'll have a tool that does a text to cipher MCP. You'll have a tool that does, whatever it is. And the system will determine which set of tools it needs. It will bring kind of the relevant context back, figure out if it needs to do anything else before it surfaces those results. So it can add complexity. I mean, anytime you're stacking and layering these things on, you're adding complexity, but it can help you prioritize what things are most relevant depending on the type of question you're getting or the output you're looking for.
Oh, my mind is spinning because I don't know. I guess I just kind of want to see it.
The possibilities are endless, that's for sure.
Yeah, and that was true for before we had this podcast. I felt like that was true.
Yeah.
And now I'm just, it's even more. It's like infinity plus one. What is that?
Yes.
I don't know.
It's a bit overwhelming for us advocates and developers and everybody else too, I'm sure.
Like, I just want to go out there and like, can't you see the possibilities? Wake up, man! Whatever. Okay, so we definitely have to talk about it. So there's, for people listening, the takeaway here is neo4j.com/Aura GB or just Aura.
Just Aura will take you to the page.
Okay, that's part one. Part two is start.spring.neo. If you just want to use an amazing world-class genre-defining graph database that's been around for nigh on 20 odd something years, I think, go to start.spring.neo, choose Neo4j, and you'll get the Spring Data module there. Works a plum. It's just amazing. By the way, does the Spring Data Neo4j stuff support GQL now, or I haven't tried it?
I believe so, because Cypher is GQL compliant, so it should. Yeah.
Oh, so worst case, you can just embed it into your Cypher queries.
Yep.
Okay. Oh, they modified Cypher to be GQL compliant.
Yeah.
So for people who know, when you use Spring Data Neo4j, you literally annotate. You just take a regular Pojo and annotate it as your node, and you can then use the Neo4j template or a repository with query methods.
Yep.
And it'll do graph queries on your. It's just the same old experience you've experienced everywhere else. It's just with a boss sauce like legendary database in the back end there. And then for the AI stuff, also start that Spring.io. Choose Spring AI and choose look for Neo4j, and you'll see a vector store option there.
Yes.
Add that to your build, and off you go.
Yeah, and actually, too, I haven't had a chance to play with this yet, but there is also a start.spring.io. There is a Neo4j chat memory dependency you can add as well. Again, I haven't toyed with it just yet, but I keep seeing it out there going, oh, I really need to get to that. So
we should try that in the next live hacking thing in a minute.
Yeah.
That's amazing. The Neo4j seems like it's always been a great choice. I mean, the thing that was like made it, the thing that put it, the killer app, the killer use case. Every ecosystem, every technology has to have a killer app. For Neo4j, it was like the recommendation engine. Like if you want a recommendation engine in a box, you want to like, your manager tells you need to have a recommendation engine, and she says you need to have it done like today.
Yeah.
Well, guess what? That's too much time. You've got Neo4j. It'll be done as soon as I can get the database in there. I've got it built.
Well, looking at what we've now termed as Neo4j magic combined with the Spring magic, I mean, just kind of makes a really nice pairing. So
yeah, wonderful. And so that was always true. It's always been a phenomenal database. It's not just a solution for certain use cases. It's the best, and it's not a question. And by the way, I don't know that that's true for everything. Like Redis is really great at key value, so it's really, really good. Nobody would argue that it's not good at that use case.
Right.
MongoDB, I don't know what it's like unequivocally the best at, I'm sure there's a use case, maybe I'm just missing it. I don't know, but my point is Neo4j, there's scores of graph-centric use cases for which it is not just a solution, it is the best solution. So that was always true. It's been true for years. Big fan of it. But then now it just seems like the world kind of they another killer use case, the AI era.
Yep.
Um, I don't know
Yeah,
a
the
database
opportunities
that's
just
more
continue
famous.
to expand there.
Yeah. Ah, okay. Final set of questions here as we
Sure.
wind down. Are you on the internet? Do you want to be found? And if so, where can people find you?
Sure. So whatever social platform, the main ones I keep up with are LinkedIn and X. I'm usually posting pretty regularly on both those channels. Also available via email if you want to reach out to me and ask me questions about data, technology, all the sorts of other things.
Is that right?
Yes, yes, that is correct. And then, yeah, pretty much anywhere it's JMH Reif. And then I also do have my own website, and all my social links are on there as well. So jmhreif.com. And I have a blog, a tech blog there. I also usually try to keep up to date with what events I'm going to be uh, visiting in the coming months. I try to have that there. Background information, social links, all of that is available on the website. So
Amazing. What would you tell people? Uh, like uh, you've got these portals. Where would you say is the most interesting, lively place for young people to participate in the conversation right now for your community and
oh yeah,
whatnot?
community.neo4j.com.
Okay,
We
very
also
good.
do have a Discord, if that is preferable. So it's the community.neo4j.com is more like traditional forums. And then we have a Discord channel as well. Those would be the two platforms I would definitely look at if you just want to
I didn't
connect
know about
on
the Discord.
Neo4j stuff.
Yeah, oh, that's really cool. Okay, thank you for your time. Appreciate
Thanks
it.
for having me.
Cheers, everybody who hung out today. Thanks for hanging out, and we'll see you next time.
Sounds good.